This
Right.
conference will now be recorded.
Here, very good morning to everyone. So today's agenda, we are going to discuss about this DevOps or flow. So from development perspective up to implementation perspective. So DevOps flow or DevOps life cycle and what are all the tools which forms the part of this flow we are going to discuss. The tools that we are aiming at for our discussion here is version control tool like Git, and GitHub is a public repository where we can keep all our repositories, all our application files, project files, everything that need to be shared by the project member can be held on a GitHub repository. You can consider this in terms of analogy as a cloud storage. GitHub is a cloud storage analogy. So here, similar to GitHub, we have a GitLab, we have several tools. Okay, with respect to Atlassian, we have several tools. So if time permits, I will let you know about GitLab also. And then the Maven is one build tool, the tool that we are covering under our curriculum. Similar to Maven, we have JUnit, we have Ant, we have Gradle. It depends upon what sort of programming language, what sort of application that we are using. Accordingly, we can make use of the tools. So here, this Maven is used for Java, Python, and all other stuff. We can make use of Maven. And Jenkins is one of the most widely used CI/CD tools, continuous integration and continuous delivery. And then here in Jenkins, we will be focusing more on Jenkins. Up to 15 sessions, we will be devoting on Jenkins. As I already told, for Git and GitHub, it will be around 7 to 8 sessions. For Maven, it will be around 2 sessions for Maven. And Ansible, infrastructure as a code. So then for Ansible, again, it will be around 10 to 12 hours. And Terraform, and again, it will be around 10 plus hours. So here Terraform is used for a multi-cloud orchestration tool. Multi-cloud orchestration in sense. So everywhere you can find cloud, cloud finds the key role. Here you can get some resources from one cloud, that is AWS cloud. You can get another resources from Oracle cloud, third resources from Azure cloud, and you can logically form a group, and under a single control, you can develop your application. For that, you need to make use of orchestration tools like Terraform. Okay, so important. So here Docker and container, and for running containerized applications with high availability, we go for container orchestration tools. So Docker is a container runtime. We have orchestration tool Kubernetes, and then for Docker and Kubernetes, so we will be allotting minimum of 20 plus hours. Okay, altogether. So Kubernetes itself, we are handling separately for 35 plus hours in terms of certification. And to Docker itself, I have a curriculum for around 25 plus hours for certification. So that is for DCA, Docker Certified Associate, and this one for 35 to 40 plus hours, this one for CKA certification, CKA and Kubernetes Certified Admin, Kubernetes Certified Application Development. Okay. So, and Kubernetes and Docker, and followed with we have some monitoring tools like Prometheus, Grafana, right? So used for the application monitoring, used for monitoring the container. For all this stuff, we use this monitoring tools. Discussion of monitoring tools comes around 6 to 8 hours of discussion, and then we will be having some basic Python script. Python script. So some automation. We can do some automation associated with the Python script. It comes around 4 to 5 hours of session. Here in Jenkins, we will be dealing with another script for pipelining. Jenkins scripted pipelining. We will use a script called Groovy script. Groovy script. Okay. So these are all the two scripts that we make use of it. This is for automation. This Python script can be used along with this Terraform, along with this AWS. So in terms of cloud, we will be using this AWS cloud. Since all guys are aware of AWS cloud, so I am leaving this discussion. So those who doesn't aware, I will share a video session of mine. Then you can go through that. So minimum, if not, AWS needs minimum 8 hours of discussion. Okay. So
Yeah, Raman, what we can do is, I mean, AWS, you can, I mean, myself and Sridhar already attended. So,
yeah,
I mean, if Sandhya and Nivedita needed, you can send them the videos and we will use more of this for DevOps, right? So,
that's what I conveyed.
yeah.
How can people do by any chance can use like Google Cloud or Azure Cloud? Because I mean, for anybody to be introduced in one form or other, AWS or other. So can we use the other type of cloud?
For what purpose?
For demoing all these things. I mean, AWS, I'm sure you use the content and you can use it, but instead of AWS cloud, can you use Google Cloud or something like that?
Nothing. So what we are using here, one and only service here is that EC2 service alone. So I will also let you know how to launch a service in the same thing. So if you are aiming at some other services, then it will be helpful. This one service is enough for us. For entire, we are going to take only the infrastructure from AWS.
Okay, sure. I understand. Yeah. Or if you want to be just for the other three types of cloud, Google Cloud, Azure Cloud, just half an hour introductions. Yeah.
So here we will be using those sort of things during our Terraform discussion.
Okay, sure.
Okay, since mandatorily it is mandatory that I need to launch a resource in Azure, I need to launch a resource in Google, how to integrate under Terraform, and that we will discuss under.
Sure. Definitely, that will be helpful. Yeah.
Yeah. Apart from that, there is nothing. Just launching the instance alone, it will differ in terms of that UI. Apart from that, once the instance has been launched, connecting with an instance and working with the instance is same, whether it is AWS or Oracle, Google, whether it is a physical server, all other things are same.
Okay. Yeah.
So I am planning for a Google data engineering session that I will let you know. This is for another client, for direct one-to-one client. A company, data engineering, a company by name NLB services. Again, it belongs to, I think, so Atlanta. So that curriculum, they are paying more. every day it is a 4-hour session, 7 to 11 night. Okay, so yeah, so in terms of monitoring, Grafana and Prometheus, and then finally ELK stack. So for this ELK stack is especially for this containerization, performing, getting logs and debugging in containerized application development environment. So Elasticsearch, Logstash and Kibana. Okay, so all this stuff needs again up to 4 to 5 hours of session. So this is all together the overall session. Also, we will let you know some minimum of 5 to 6 use cases using which all we can develop some small applications using which how all these things can be integrated. How you write a code from GitHub and how Jenkins does and how Terraform, all these real-time use cases, 5 to 6, minimum 5 to 6 use cases I will let you. Okay, by combining all the stuff, so that at the end you have a clear understanding. So here the knowledge that you gain here after this curriculum here is you can put in your profile up to 3+ years of experience. To that extent, everything will be covered. So profile can have Devops 3+ years of experience. A guy with real experience of 3+, the same knowledge you will be acquired. So this is what about our curriculum. Okay. So next week alone, for this week alone, we have sessions on that is on your Friday, Saturday, and Sunday of US time. Okay, so after that, my session, my AWS session will be over. From next week onwards, we can have sessions for 6 days a week. Okay, the same morning. For me, it is 7 a.m. IST to 8:30 a.m. IST. Okay. 6 days is not a problem, I think so, for all you.
It should be okay, but we'll see. Yeah.
Normally we go for 4-day session, so additional 2 days, or we can go for 5 days of session. No issue.
I think we can go for 5 to be. I mean, leave the
Saturday and Sunday. You can take it for doing practicals, not free. Okay. What are all the things that has been taught on 5 days? You can go through on Saturday and Sunday.
Yeah. I think 5 days will work for me as well, because usually on the weekends is when I do my PhD work. So I think 5 days is suitable for me too.
We can make it on Friday. I will give you some assignments on Saturday and Sunday. You try to do those assignments.
Okay.
Yeah, yes, good. This is from next weekend. Next weekend, in sense, a week after the coming week.
Okay.
Okay. I have 4 or 5 classes to complete the AWS, and after that, I will take a break for AWS for 1.5 months, so that within that I will try to complete this.
Sure, thanks.
Okay, let me talk about the role of each and every tool. So yesterday we discussed about the drawbacks associated with the waterfall model, and then how waterfall, one of the main drawback associated, it took a lot of time for application development, more time. Okay, minimum 6 to 8 months of time for developing the application. And here, the cost, the resources involved will be more resources and more cost. Not all the resources will be engaged fully. In majority of the time, the resources will be kept idle. These are all the problems associated with waterfall. To overcome from that, we go for a model called Agile. In Agile, we have a sprint. So the entire process has been divided into an individual components. So independent components. Okay. So so in this example, yesterday we took an example of a loan application, a loan management and development for let me take an SBI bank. So here we develop a loan for, so in terms of the loan, we have personal loan, we have a home loan, we have vehicle loan, we have agri loan, and we have education loan. So instead of developing everything as a single entity, as of in waterfall model, what we does in case of Ajay, so we will split the overall functionalities into independent modules. In this example, we have 5 modules. We will take first module and develop the module. Then that we call it as a sprint, sprint one. The sprint duration will be of 2 to 3 weeks, depends upon the size of activity that we want to do and depends upon the number of members. It will be minimum to maximum of 3 weeks. So every 3 weeks once, client assured of delivering a particular component with respect to this loan management. The week one, so sorry, the first sprint, this personal loan model has been given to them, and they start working with personal loan. So they don't need to wait for a long duration for receiving this application. Every month they will receive a copy, they will receive one model, they start implementing. This we call it as Agile. In Agile, it focuses on developer perspective. It improves a lot of things on development perspective. It facilitates fast development. But on the other side, the operation team faced a lot of issues. Operation team want to change the infrastructure, want to add some new features, want to install, want to uninstall with respect to the every sprint. So it resulted in a lot of tussle between the development and operation team. So Agile, even though it focuses on developer perspective, overall, it faces several issues because of the non-cooperation between developer and operation team. To overcome from that, we come across this current concept called Devops, which is a culture using some set of automated tools that make both the development team and operation team work in together in conjunction with together. Okay. So by the way of developing your application using this Devops, the advantage here is you can develop your application first with less amount of resources, less human resources, and as a result, the cost will be very less cost, and not compromising the quality with the high efficiency. Your application's efficiency will be very. How it is possible? By reducing the human resources and by making use of some automated tools that we have listed. By using set of automated tools, we can able to achieve this opposite. Okay, so we are going to talk about the role of each and every tool. So let me take a, okay, there's now we are going to talk about the first component. Yes, so Jenkins here forms a DevOps, we call this a CI/CD. CI stands for continuous integration, and CD stands for continuous delivery. Under continuous integration, we come across first one, continuous development. So I will let you know each and everything. Continuous development, and then after that, continuous upload, continuous build. So creating of this build will create your artifact. Continuous testing, Okay, and then continuous then continuous delivery. Here continuous delivery. Here the application is deployed. Here continuous build. Here after build, continuous deploy. After that it is tested, and once it is tested, now you go for this model continuous delivery. And then after delivery, we again follow the continuous monitoring and the life cycle continues. Okay, this is the process involved. Let me discuss each and everything and which component is involved in this activity. Okay, so continuous development done by the programmer, and then the programmer after development of the code upload the code into a repository like GitHub, a public repository like GitHub, so which is a version control system repository. And by making use of tools like Maven, they will develop a project artifactory. Artifactory is nothing but executable version of your application. This artifactory can be managed using some tools like JFrog Artifactory. Artifact is exe form of your project, and then everything is perfect. Your build is okay. Then you need to apply test on that build. Therefore, that build which is from the development machine. So we have a development environment, we have a QA environment, we have a production environment. With respect to application, these are all the three environments. Okay, the environments associated with our application development. The developer works with this environment. So in this environment, check the developer what it does. They will start develop the application. The application, once it has been developed, need to be uploaded into a repository, a GitHub repository. All the people working in the project will have the source code in the GitHub repository. The source code, the repository that we are going here, the developer machine will have a tool Git, which is the version control system tool. Okay, Git is a version control system tool. GitHub is a repository which keeps tracks of all the source code associated with the project. Okay, which can be configured as a public repository or private repository. So let me assume here we are developer. There are three developers. The developer, one developer Ram, another guy Raj, and third developer Sridhar. These are all the three developers, which is whom they are going to develop an application. Okay, so let me take the loan application, the loan model of the Pro. If we take this as use case, in this loan model, they are going to develop the personal loan model. So the Ram takes care of PI part, Raj takes care of the business logic part, okay, and Sridhar takes care of again the business logic part. So here the code which is developed by Ram is 1.java. Let me take. So here Raj code is 2.java. This is the file associated with the Raj code, and Sridhar's code is 3.java. So where they will do, they will develop on their own laptop. Ram, Sridhar and Raj develop on their own laptop. In their laptop, they have a Git, which is for what purpose we need to go for Git. It is a version control. VCS stands for, it is a version control system. So what are all the changes that made to the source code that will be recorded by VCS at any point of time? If you do a change, for what reason the change has been made, who did the change, so when the change, what's the date and time the change has been made, all those things will be recorded. The advantage is at any later point of time, if Ram leaves the project and another new person logged in into the project, by looking into these reports of, by looking into the logs of version control system, a new guy came to know for what reason the code has been modified and who did the modification and so on. So also it will maintain multiple copies of your application. You developed an application on Monday, you did some modification on Wednesday, you did some other modification on Thursday, means all the three copies will be maintained here. Okay. So at any point of time, if you want to revert back to any one of your old version, you can immediately revert back by maintaining this sort of versioning in GitHub and Git. That's the advantage of going for this version control system. Okay. So here it develops the application. After development, this is development, continuous development. Ram develops its code, Raj and Sridhar. After that, what it does, the developer will push the code, upload the code into the public repository. A repository will be created. All the people who forms the part of the project will share the code in the repository. You can have GitHub, you can have GitLab. There are several repositories on that. Okay, so here once the code has been pushed into the repository, okay, what do we need to do? So the code need to be that one.java. This is the source code. It need to be check for syntax and semantics. We need to build the artifact. Therefore, we need to build, we want to create a class one.java and two.java. After that is, we need to compile and build. We need to compile the source code and build the artifact. Two.java, after compilation, if you check for semantics, everything is perfect, two.class. And three.java, which is developed, we will have a three.class. Who did this? Who did this? Here we make use of tools for compilation and build. We make use of tools like Maven. Maven is a build tool, so we will be configuring Maven. Here there will be a Jenkins server who takes care of all the CI/CD activities. We have a Jenkins. What Jenkins does? It will continuously look for the GitHub repository. When Jenkins is configured to look for a GitHub repository, if there is any developer develops a new file and upload the file, okay, one.java, RAM upload one.java, immediately Jenkins will take the file, and this is a continuous upload. The RAM uploads the file. After development of the code, uploads the file. Jenkins, what it does, it will perform a continuous download. It will perform continuous download. Okay, this download, it will download the file and it will invoke a tool intermediately. It will invoke a Maven. What it does, Maven will take that file and it will check for syntax and semantics. It will compile the file and it will create a class file. Okay, it will create a class file. Similarly, Maven, what it does, under the control of Jenkins, once Raj completed his code 2.java and pushes the code into the repository, Jenkins will download the code and invoke Maven to compile the code to form a class file. After that, so the entire three class files associated with this loan module. Okay, personal loan module consists of three class files. All the class files will be converted into your artifact. It may be a web archive, or it may be a Java archive, or it may be an enterprise archive. Depends upon, it may be exe file. So if it is PHP, it may be a PHP file. So taking all the associated class files in this example to form an artifact, to form an executable version of your project file. Executable version of a project file is called artifact. Who does? Again, Maven will does. Maven will compile and Maven will create an artifact. Now you have artifact which is created here. Now the artifact, okay, so the developer's code. Now the artifact is ready with the repository. So let me take, this is a project.jar, the loan, okay, personal loan project.jar. This is the artifact. Now the artifact needs to be moved from the development environment into QA environment. For what reason? Here you will be applying some tests. You will be applying some tests and verify whether with respect to the user's requirement, with respect to the required functionality, everything is working fine or not. Okay,
one second, Raman here. So, so the class files, right? Maven does the build, so the Java files become .class files, and Maven also makes the executable. You mean the artifact?
Maven will have 7 life cycles. One first life cycle is build a life cycle, and another life cycle is creating this artifact. That's all. We'll discuss the 2 hours of discussion is Maven. With Maven, we'll let you know all the.
Where is .jar stored? In the same GitHub?
Yeah, in the public repository itself.
Okay. It's GitHub.
Normally, the final files, everything will be stored there in the repository as well as in the user machine. That we will discuss during the Git and GitHub. In Git, there are 2 types of version control system. One is centralized version control system. Okay, so second one is distributed version control system. In centralized version control system, those things will be shared only on the central repository. Okay, so that I will discuss during Git. What is centralized and what's the difference in Git? A copy will be there in GitHub as well as on all the developers' machine. The same copy will be there. The entire project's copy will be on all other project developers' machine who forms the part of the project. In both the way, in both the location, it will have a copy.
Okay.
So when a new guy enters, so now Sandhya has been okay. Sandhya has been
Yeah.
important to the project. Okay, now what Sandhya needs all the files associated with project. What happens? Sandhya can connect with the GitHub repository and can download and keep a copy of all the files, and she can develop her own file 4.java. The functionality associated with Sandhya's assignment is 4.java. She can develop the file, and once the file has been developed, she can push into the repository.
So
Is it
would it
clear?
any time all the copies will be maintained without combined together? I mean, until we finish the project, or how long we are going to keep these individual
It is
pieces?
like a directory which pulls all your files.
No. Question is, till what stage we maintain all these individual copies, Java 1, Java 2, Java 3, Java 4? Will it be until going to the production, or just in between some consolidation can be done?
Once it passes the test, once it passes the test QA test, we no need of class files. Those class files has been totally combined into a jar file. A single file will be there. You can drop all those files.
Thank you.
But Sridhar, those files are but at least till the executable is made, right? So you need to have all the different phases, right? Kind of, if something is wrong, you can go back to that particular version.
That thing will be kept in the local machine. The local machine. It is your choice to decide. Okay, so if you have enough resources, it is not automatically removed. If you want to remove the space, if you want to keep space in an optimum manner, then you can manually remove it. If not else, it can be there in repository there.
Yes, safe. It's better to keep it for some time. Yeah.
Yeah. So if you have this artifact, from this artifact, what you can do, you can unzip this artifact and you can get back these files also. While this progress, you will have understand. Just today's agenda is a brief overview of how a flow will be like. Okay. So let I assume these are all the developers. These are all the files. In the developer machine, we have installed the Git in the developer machine. The developer's laptop, we have Git in the developer's laptop, which keeps tracks of all the changes made to the file. The Git will maintain the first version of Java. So here, second version of Java. In case if it is modified, that I will let you know. Okay, so these are all the content associated. Here, it will be shared in a repository. There is a public repository. The repository, the GitHub repository. So here all the files will be there. 1.java and 2.java and 3.java. All the files will be there. Once the file has been uploaded, so what happens here? So the Jenkins server will came into the role. You have Jenkins configured on a server. The Jenkins server will continuously monitor the repository. It is configured to monitor the repository. In case if there is any new file that is uploaded, it will download the file. And Jenkins will invoke build a tool like Maven. You can have a Maven, Ant, Gradle, any tool as of your choice. So Jenkins can invoke all those tools. This is a plugin. These tools will be acted as a plugin. So you want to add Jenkins as a plugin. If you want Maven, if you want Ant, if you want JUnit, whatever thing with respect to your application, you can make use of it. Maven will take and Maven will create this class file. It will compile and create this class file. 1.class, 2.class, and 3.class. And after creating a class file, it will club all these things into a jar. Okay, that is your project.jar. This project.jar will be kept in a separate repository, which will be maintained by a tool called a JFrog. The JFrog repository. If not, Maven itself manages this jar file. This is the execute. This we call this as an artifact, the executable version of your project. This artifact is going to be now just once this process has been over. This is the first process. As I told, this is the developer develops continuously, continuous development. And the second thing, continuous upload. Third thing, Jenkins look for, and then it will perform a continuous download of the new file, and it will perform a continuous build. That is building the artifact. These are all the first four phases which forms a part of continuous integration, CI. Okay. So after your artifact is ready, so your artifact so need to move from these are all developers machines. These are all development environment. So what you need to do, once everything is perfect, your code is working fine, you want to test the functionalities of the code. For example, you have a username and you have a password screen. This is your first screen. So you want to check, you want to give correct username and correct password. Then only it should take you a perfect login. If username is correct, password is wrong, then you should not log in. If username is wrong, password is correct, then you should not log in. If both the things are correct, if both the things are wrong, it should not. These are all test cases. These test cases will be written on a separate file. So one.java test file and two.java text file. Like the test associated with the corresponding module, again it will be in the repository. So what happened here is after forming of this artifact, project.artifact, Jenkins what it does, it will take the artifact. Then you have a QA server. You have a QA server. The QA server, we have testers. Tester what they have, the testers once again in the repository, GitHub repository, they will maintain the test file, the test case file. That is one test.java file. Okay, and the two test.java file. The test case associated with one test. In the test case, assume that this is the username and password is the screen associated with one test.java. They will have a test case. Test case one. If both the username and password correct, you should have a login. If username is correct and password wrong, or password correct or username wrong, you should not log in. It should send a message. Like those sort of things will be tested. Whether that particular module satisfies the test case or not. That thing will be done by the QA environment. Therefore, your project.jar need to move from the development environment into QA environment. Is it from the development environment into QA environment? The process of moving this project.jar from development environment into QA environment, we call this as a continuous deployment. The continuous deployment, moving your source code, moving your application from one environment into another environment is continuous deployment. Okay, so now it is deployed in the QA server. You have a QA server. In the QA server, it is deployed. In that, what it does, now it will download the source code. Once again, Jenkins will take the source code, that is the test source code, and it will run that source code on the application which you configured on QA server and verify whether it satisfies the user requirement or not. If not, here if so the code developed by Raman on.java. In this module there is a problem. In the module there is a problem. Immediately what it does, Jenkins will send a message to one.java. Jenkins is configured in such a manner that so the code associated with one.java is having some issues. Yes, Raman, please kindly revamp the code, change the code. And what Raman does, now it will, according to the instruction given with respect to Jenkins, Raman will create the second 1.1.java, the second version, and he developed that and he upload that into the repository 1.1.java, the first version of Java. And then Jenkins what it does, it will look for a new update, it will take the update and it will again once again compile and integrate with the existing artifact. Now that particular module alone will be integrated with project.data and again it will be tested. And if a test okay, now the problem that we have faced with respect to the initial process has been resolved in sense the test will be success. Once the test will be success, okay, you have a unit test, you have integration test, you have performance test, you have user acceptance test, those sort of tests. If everything is perfect, then your application is ready to be departed to the end. Now you have a third server, production server. So the application, that successful tested application, that project.jar from PA server will move to the prod server. So
Who will move that? Is it the job of the Maven or
Jenkins will do that activity.
So Maven's job is to compile, Jenkins' job is to
Maven
deploy.
is Maven is to compile and create artifact.
Yeah, the
Taking
project, let's say the jar file, right, and the artifact, right, is created after the Maven build. So it
yeah,
is stored in JFrog repository, let's say.
yeah, yeah.
And who is deploying it to QA environment?
Jenkins.
Jenkins. Okay.
That is pipelining. You won't, I think so. Sridhar talked about pipelining.
Mm. Yeah.
So
Jenkins pipeline will take it from JFrog and deploy it. Okay.
yeah, everything, all the process, downloading and compiling and keeping a copy repository, taking the copy and moving the copy into QA, apply test cases, and from the QA move into the product. That we call this as a pipeline, scripted pipeline. For this, we will be to make this thing automated. What you need to do, just Raj develops the code and puts the code into the repository. That alone Raj need to do. The code will be taken and it will be checked for syntax, semantics. In case if there is an error, here itself it will be informed to Raj, and Raj need to revamp the code. Okay, need to change the code according to the error and push the code. And everything is perfect. Then the code will be moved to QA server for testing, and from testing to Raj. Everything will be done in an automated manner. Okay, initially it needs a manual intervention. So Sridhar develops the code. He need to compile the code, and he need to then all the codes need to be taken by the build engineer, and build engineer will create an artifact. Everything need to be done manually instead of manual activity. Now everything is automated using this set of tools. Yes, up to this, okay.
Yeah.
Then if a test is success, then that particular artifact from QA server again move to the production server. In the production where the end user starts working. So the movement of server into the production, we call this as a continuous delivery. The continuous delivery will ensure all the client user can start working with an application. So once the client start working with an application, client may feel some issues. As far as their expectations, the application may not be working. They may feel some issues. Again, the client will, this is monitored. The application is continuously monitored, whether the application needed resources is there or not. So if yes, if resources is not sufficient enough, immediately this continuing monitoring, this monitoring tools like Prometheus and Grafana is configured to immediately intimate to the administrator that it is lagging in resources, immediately add resources. If not, again the client, if they give some feedback, the feedback will be immediately notified to the concerned administrator. So Sridhar, your module that you have developed needs a certain refinement. Okay, a particular component in your model is not working. So in that production only, so those sort of things will be revealed immediately. Sridhar, what it does, he will do a modification on the code and keep a version, first version, modified version 2.1 version of Java, and Sridhar uploads the code into the repository. So since there is a new code, this Jenkins will take the code and it will compile the code and integrate the code with the existing product data. Again, it will apply the test on this product data, and everything is perfect. It will move to the delivery. Here, user starts working with, and the problem initially user addressed has been resolved, and he works satisfied. This process is a continuous process. If we look into that, DevOps life cycle. This is your life cycle. Take, yeah. This we can find. It is a okay. So now we can find this is your DevOps life cycle. Okay, the code has been written, and so here we use this Git for typing the code, and it will be stored in the repository. And then, so once it is perfect, it will be built. Okay, you make use of Jira You make use of Maven, you make use of and this tool and okay. So these are all the builder tools. These are all the Gradle. These are all the builder tools. The builder once the code has been written, it is a builder to form these class files and artifactory. And after that, the third process. This is step one. This is a step two, and it is a testing. You can make use of automated testing tools like Selenium and JUnit to do test in automated manner. Once testing has been done, then it will be released using this Jenkins. Bamboo is another tool of Atlassian. Okay, it is now moved to and deployed here. This process of moving this code in from this dev server to QA server and from QA server to prod server. We call this as a deployment. Okay, how you can make the deployment can be make automated by using tools like Puppet along with Jenkins will take. Jenkins will coordinate. We can use Puppet, Chef or Ansible. So that is the needed infrastructure. You have application ready. You have application ready. You need to create the server in the production. You need to create the server in the production. Who takes care of creating? Either manually the administrator want to do. Instead of that, you can use infrastructure as a code. You can create an infrastructure through code. For that, you can make use of tools like Ansible, Puppet, and Chef. Okay. So then that infrastructure has been created, and all your application will be taken by Jenkins and it is deployed to the end user. Now it is deployed, and the application is under operation. So we can make use of
Jenkins alone can do it, or he has to have the. I mean, here, I mean, the software Jenkins has to have Puppet or Chef.
Yeah, Jenkins will invoke the Chef. Okay, he is a coordinator. He is a coordinator. Jenkins will invoke the Selenium. Jenkins will invoke the Maven. These are all the tools which does the activity, but need their coordinator. A coordinator needs to be done. What is first, what is second? That activity will be done by Jenkins. Okay,
Raman,
you want to write Ansible. You want to write a Ansible book. In this Ansible, you want to write a script. So I want 5 servers with the following configuration. Need to be launched on India. I need 10 servers need to be launched on US. And after that, if you need to write okay, this Ansible code, we will discuss how to write a code in Ansible. So at the second, 100 servers if you want, those servers across globe will be immediately installed. So it will be either installed on your on-premises data center as a VM, or it will be installed as a instance in your cloud. Okay, so initially what you need to do, or if you want to install 100 servers, the 5 server in India, 10 server in US, 50 server in UK, you need a separate administrator. The administrator will need to do manually every activity. Here, instead of that, what you can do, you can replace all the admin by a single Ansible. The Ansible, you want to write a script. The script will install the needed software along with the server on the desired environment. This is the way by which it can reduce the cost to great extent. Okay. If not, you need admin in India, you need admin in US, you need admin in UK. No need to go far. A single Ansible server can connect with all the concerned network. Here it will launch all the needed things on top of it. That is controlled by Jenkins. Actually, Ansible will create the environment. Who instruct Ansible to create the environment? Jenkins will instruct Ansible to create that. So your application is now under operation. Now you can make use of these tools like Neuralink, Senso, okay, Nagios. These are all monitoring tools. Neuralink, Nagios. Now the current monitoring tools are Prometheus, Grafana, and all those stuff. Using the monitoring tools, it will be monitored, and this is the workflow. This process continues. Monitor, and in case if there is any issue, again you want that issue has been notified, and you want to plan. Your code need to be retuned, and you need to, according to the plan, you need to code again. The code need to build again and tested and released and deployed, and this process will continuously happening. That we call this as continuous integration and continuous deploy, continuous delivery. This process is a never-ending life cycle until there is no issue. That's clear? Each and every stages, your feedback will be sent to the concerned person. In case if there is
tools like Prometheus will be, I mean, suppose if there is a problem when you're trying to monitor, I mean, product is not performing the way it's supposed to be degrading. So communicate back to the planning, coding, and the build stages, or someone manually have to do it?
It reports to the Jenkins. Jenkins will send a notification. We have a Jenkins notification catalog. We call it Jenkins catalog notification. Need to configure a Jenkins catalog. So this will send a notification. Similar to your SNS notification in AWS, we have SNS. What SNS does? You have a topic. To the topic, we have subscribers. Similarly, in this catalog, we need to give the mail ID of the concerned people. Jenkins is the
Raman, a couple of questions here. What is Bitbucket? Is it a different tool like GitHub? Git?
Bitbucket is another tool similar to GitHub, GitLab. There are several tools are there.
So, I mean, if I'm using Git, I don't need to use the Bitbucket, right?
If you are using Git, you can. Git is meant for version controlling on your client side. On your server side, you can use GitHub, or you can use Bitbucket, or you can use Git.
Okay, so Git, I can use Git on the desktop version, but for the repository, I can use Bitbucket or GitHub.
GitHub. So Bitbucket is a tool belongs to Atlassian.
Atlassian, okay. Whereas GitHub belongs to Git.
Yeah. Which one?
GitHub.
GitHub belongs to Git.
Okay,
so we have MySQL database, we have SQL Server database, we have Oracle database, we have Informatics. Everything will serve for certain purposes. Similarly, there are several companies which develop that GitHub repository like thing, that is Bitbucket. So our company uses GitLab. Okay, each and everything which depends upon the client's requirement. Globally, 80% of people okay, use GitHub. Being it is free. All the activity what we can do in GitHub can be done on Bitbucket, can be done on GitLab, everything.
Okay. And what is SaltStack does?
SaltStack, what it does is similar to this infrastructure as well configuration. Similar to Chef, similar to Ansible, it will create the needed.
Okay, just IIAC to kind of
tool. Infrastructure as a code.
Infrastructure as a code. Okay.
This is used for configuration management and creating the infrastructure for it.
Okay.
Hope to some extent I can make you understand the overall flow. Is it?
Yeah.
So somebody says pipelines wins, there's nothing. It's basically the way the cycles goes on, right?
Yes, Sridhar, please.
I mean, so I'm just trying to get clarification of a word called pipelines. What exactly we call is the pipeline and what we do there?
Pipeline means what you need. So just Sridhar need to upload the code into the repository. And taking the code, so then Sridhar writes the code in his laptop, and then using this kit, he will maintain a copy. He will upload into the repository. First step, the code need to be automatically taken by Jenkins and invoked by Maven and build the code and create the artifact. And that code has been moved into that from the Jenkins, takes the code and move to the test server where it is tested. And the code will be, after everything is perfect, the code will be deployed here. And then all this activity is a life cycle. It will be done automatically by using the script that we call this pipeline script.
Okay, just one more quick question, Raman. I mean, so first of all, let me admit I'm not a developer. Only I'm taking care of the operations. Now trying to get into DevOps. Background is DBS. So where exactly this operations guy come into picture?
So the role of DevOps engineer to configure all these things. The developer just develops the code. It doesn't do anything. Here you want to configure GitHub. You need to configure Bitbucket. You need to install and configure Jenkins. You need to install and configure.
In every role, he can play.
Except the development of the code, except the development of your testing code, all other things need to be done by DevOps engineer.
Got it. Yeah, that's what. Yeah. Okay.
So you don't need to worry about that code. What you need to aware about something basics, some scripting alone. That is enough. In terms of that's the advantage of going for DevOps. You don't need to worry. Focus more on the code. It is all the set of configurations that you want to make. Since it involves 10-15 tools, so people are fearing of getting into it. That's the reason why there is a huge demand for it. It's a matter of nothing. but it gives us a lot of advantages. A simple tool will reduce our human effort to great extent. Imagine,
Take it a little bit within Oracle. When recently started applying, then there's an opportunity came in as a DBA. You are trying to go to DBA work only, but on top of it, this environment is to create. Machine learning, AI. So they want to create kind of that kind of environment they can use as a platform. They want to create the platform can be used by different application groups. So in this job, not only that, other than the DBA, you got to know what is the what you call the pipelines, and you have to use GUI scripts and troubleshoot the problems. If there's a connection problems, anything, you should be able to do it. That is another addition of a twist of the job. So this side of the picture are not there. DBA side, no questions asked. Going to this side, they're asking a little bit how confident you are, where you are. So that's now I'm trying to get the bigger picture. This is okay.
okay,
So it can be done with after learning and everything. This side of the picture, you can extend a little bit. Yeah.
Okay, so once we are going into that with the practical, you will have 100% understand.
Okay.
Okay, so a developer, a administrator, a tester, whoever may be, can fit this DevOps. That's the demand. As I told in the Saturday session, while starting with the session, DevOps will give you an opportunity if you are a developer, and if you are a tester, or if you are a build engineer, or if you are an infrastructure. In this case, so the role of a network engineer, the role of system administrator has been erased, has been eradicated, because you no need of any system admin. Just if you know Ansible, you can write a code and you can implement that code. Using that code, you can create the infrastructure within a fraction of second.
Yeah.
So for that, what you need aware of cloud. So if the underlying environment is cloud, you need to know the basic service, what is instance, how to create instance. Then it will be very easy for you. If not, there will be a separate DevOps engineer, there will be a separate cloud engineer. Those two engineers togetherly integrated and do the activity. If you guys know both, then company will give you an opportunity. So instead of recruiting one DevOps engineer paying 2 lakhs per month and cloud engineer paying 2 lakhs for 2 plus 2, 4 lakhs per month, then they will recruit you and pay you 3 lakhs per month. The advantage here is, here instead of two independent, the one person who takes care of all the activity and with less cost, this is the benefit to the company. And your benefit being you aware of the second step, you will get a 50% hike than what a normal guy will get. That's the advantage of going for knowing more than one related technology in this perspective.
Got it. Yeah.
Hope is it clear?
Yeah. It makes sense. Yeah.
That additional effect of 50 to 100 hours will make your packet filled with the additional 50% hike. That's all. If you are a CEO of the company, you also take the decision, is it?
Yeah.
So this is all about the CI/CD process and that involves.
Can you share this? Can you share this picture along with the recording today?
Oh, I will share.
Yeah.
Yes, I am getting from Google only.
Yeah, but if you are able to copy, otherwise you'll get it. But it's because along with that, if you get it, you'll at least remember.
I will give you the entire documentation. For DevOps, I have all the codes and that stuff. I will share everything.
Got it. Okay.
So this is the life cycle. Now you can find this is the life cycle. So development, okay. So operation, so integration to the existing environment, testing. So after that, for every phases you will get a feedback. Every phases you will get the feedback. Okay. This is the DevOps life cycle. So now we will be moving on to our discussion on the first tool. Okay. What is Git and how to install and configure Git. So Git. So what is Git? Git comes under version control system. It keeps tracks of all the changes that you made on the source code. It keeps tracks of what are all the changes that you did on the source code. So, okay, so who did the change, when the change has been made, for what reason the change has been done. Okay, so if there is a change in source code, so this is 1.java, which is developed by Raman. Okay, at any point of time. So this code need a certain refinement, or based upon that client's feedback after it got implemented in production, or based upon that QA's feedback, the code will be refined. 1.1 version, 1.2 version, like you can have multiple versions. Those versions will be managed by this Git. Okay, where the source code will be? The source code will be managed in a public repository called GitHub. This GitHub hub dot okay github.com. So this is a github.com. This is the public repository which is managed by the GitHub community. Similar to GitHub, you can have a tool like a Bitbucket. So you can have a tool like a GitLab and so on. There are several tools. You can make use of any tools. This is your server-side component. This is a repository. For in your machine, for your client, you can use Git. For your client, you can use Git. Okay, so what Git does, the version with respect to this version control system, so it will keep track of who did the change. So Raman did the change. When the change has been made, the change has been made on the following date. So 30/1/2022. Okay, that time morning 8 a.m. IST, the change has been made. For what reason the change has been made? So because of the feedback from client, a particular functionality need to be refined. For that, the change has been made. Those sort of messages will be incorporated. So at any point of time, so now that it will be maintained. It will be maintained in forms of logs. So at any point of time, laterly, instead of Raman, a new person, Sandhya entered into that project. Okay, so if Sandhya looks into the logs, she can able to go through, then what are all the things that happened on that source code from beginning, then what is the current state, so for what reason that modification has been, everything has been completely revealed because of the logs which is managed by Git. So that's the advantage of going for version control systems like Git. Okay, so in terms of this version control system, so there are two types of version control system. One is the centralized version control system. The second one is a distributed version control system. Centralized version control system. The second one is distributed version control system. Okay, Git comes under the distributed version control system. Okay, so for centralized we have SVC, we have subversion control. Okay, subversion. We have Perforce. These are all some tools. Perforce. Okay, so we have CVS. These are all some tools which is coming under centralized version. We have a Git. We have Mercurial. These are all some tools of distributed version control system. Difference between this distributed and centralized version control system here is distributed versus centralized version control. So in centralized version control, let me copy and then make a paste. In centralized version control system, okay, let me take this scenario. So this is our logs, okay, make a note of it. Now you have a developer. You have a repository. You have a central repository. So okay, the central repository, the source code will be there. All the source code. Here assume that you have the source code developed by the developer Ram. This is Ram's laptop. 1.java. He uploaded the source code. So 1.java will be here. It not be here. And then here. So Sridhar 2.java and he uploaded the code into the repository. 2.java will be shown. And similarly, Raj developed 3.java and he uploads the code on 3.java. All these code will be maintained only under central repository. So if Ram wants to, so Ram got a feedback. So Ram, you want to revamp the code. Then what he need? He won't have a copy of the code. He won't. He will type the code and upload the code. In the centralized version control system, the code will be maintained only under central repository. For each and every activity, Ram connects with the central repository, download the source code, and he did the modification. Once again, push the source code on the central copy. At any point of time, Ram is dependent upon this the central repository for all these activities. Assume that if there is a failure of connection between Ram and central repository, Ram couldn't do anything. So this is the way by which the central repository has been architected. Okay, the centralized repository alone will contain all the source code and working copy of the source code. Whenever it needs to be downloaded. It needs to be downloaded in the local machine. This is Raman's machine where a copy has been downloaded and it will be there. After Ram completed, it need to upload back to the central repository. Whereas on a distributed version control system, everything will be there on all the machines. Here, the code which is developed by Ram, along with that, the code developed by Sridhar and code developed by the codes associated with a particular project will be managed by Ram as well as Sridhar, as well as here Raj. Along with that, it will be managed in the central repository. At any point of time, Raman does not worry about that central repository. Being the entire application's code is up to date, it's synchronized in its current working directory, he can work with that. Laterly, he can develop a new model. He can develop a new code, 4.java, and laterly, if you push the code that in 4.java, so Sridhar and Raj can connect with that and pull the code. So at any point of time, all the developers working with the project will have all the source code associated with the project. So it is not dependent upon the central repository. So they can do the activity. Once the activity has been over, at the end, they can push all those updated things to the central repository. Okay. So this is all about how distributed version control system, and the distributed version control system will have the copy at center as well as the same copy will be managed on the individual machine. Whereas the centralized version control system will have the copy only on the central repository.
Let's say two users are working on the same file. I mean, how does it work out? Let's say I need to update something, and
Ram is restricted to work only on the file created by him. In this manner, it is using access control. Ram can't do any modification on the file on Sridhar. He can view the content of Sridhar. He can make use of the file of Sridhar. Okay. So for Ram coding to work, if there is a dependency on Sridhar's file, he can refer it. He can't do any alteration.
Okay.
So what we can do? So one of my friend who is working for years is actually Mr. Jay Kumar, who is expertise in this Scrum and so on. So I will engage him 1 hour session with live what is Agile, okay? What is Agile and other stuff, what we are discussing, we can engage 1.5 hours. I will talk to him and I will ask him to take a session for us so that you have a much more clear understanding.
Yeah.
He may be a right guy in this perspective. He may not aware of Devops. Okay, so the tools and things, but he's a Scrum, he's a good Scrum guy. Then he will let us know all this stuff for 1 hour, 1.5 hours. Okay, I will talk to him and let you know.
Yeah, one question I have on this one is, let's say I'm developing a file and 2 other people are developing, right? So what are all the files that need to go into a jar file, right? Let's say. Who is making that decision on what all are files going into a jar file?
Yeah, here you are architect. You have this team. This team development team will have an architect. Will have a project manager itself. So Ram pushes the code repository. That whether to accept the code or not, it will be decided by the project manager. Here in this Jenkins, we need to get a acceptance. So it is not pushed immediately. It is not okay. The project after project manager's acceptance only it will be pushed. how it is done. So by using some boards like a Kanban board, there are several tools using which this can be
Kanban board. Yeah, Kanban board. Okay.
board. But for that, only I am insisting that we can make use of Jaykumar. Okay, so I will talk to him so that he will give with more clarity than me.
Yeah, maybe if, with an example if possible, right? A live example.
Live example. So because so wherever we find the right people, we can incorporate right people in our curriculum. No issue. I also gain more information from you.
Yeah.
So he's a citizen. He got, I think so, green card. His wife and kids are in US, but for taking care of his father and mom, he is with India for the past 5+ years, visiting US at least yearly once. Rather than reverse visiting India yearly once, he is visiting his wife and kid only once. Such a nice guy. I will talk to him and I will arrange this session any one of the day in coming days. Okay. So now is it clear? So what's the difference between a centralized and distributed? If you look into the difference, the centralized versus distributed versus control system. What's the difference between centralized and distributed? The main difference between centralized and distributed version control, in centralized version control, the versions are saved in the remote repository alone, not on the local machine. While in distributed version control, versions can be saved in remote repository as well as in local repositories of the concerned. That's the advantage. Why is distributed version control system is more popular than central version control system? Because every client or user can work locally and disconnected, which is more convenient than dependency upon the central source control. That's why it is called distributed. You are not relying on the central server. Okay, you can do you can clone the entire thing. That means you can copy the entire code associated with the projects into the local and you can work with that. Once everything is perfect, you can push back to the central repository. Whether that pushed code need to be accepted or not will be decided by the manager. So we will configure Jenkins for that acceptance criteria. Okay, this is the advantage of going for a centralized version control system. Sorry, distributed version control system. This Git is a centralized. Git is a distributed version control. Git and Mercurial are decentralized. Okay, that is distributed version control system. So both allow multiple developers to be working on the same source code, download to the local machines at the same time, reintegrate commits and change are made and tested. This is neat. Once you can do a change, in certain cases. Okay, RAM downloads the source code. Along with that, here serious code also will be there. So for running that RAM's component, it needs a serious component. There is a dependency. Okay, RAM can do a modification, and when you push the modification, before being integrated into the repository, it need a confirmation from the manager. Why so? Because RAM couldn't do any mod function on its code. The first code, it is working perfect. The second code, it should not induce anything which is going to perform a malfunctioning. Therefore, every push need a confirmation from the manager. Okay, in such a manner it is articulated. Is it clear?
Yeah.
So we can use this apart from that. What are all the things? So SVN is the centralized version control system. Okay, advantages. Why is Git preferred over? Okay, all these things. So these are all the differences. Okay. So these are all some examples that we talked about, the distributed Git and CVS, purpose. Okay. So the main difference between the centralized version control system keeps the history of changes on the central server, from which everyone requests the latest version of the work and pushes the latest changes to it. This means that everyone sharing the server also shares everyone's work. Okay. So on the other hand, a distributed version control, everyone has a local copy of entire work history. That means it is not necessary to be online to change the revision and add changes to the work. Okay, so these are all the advantages of going for a centralized version control system. So we can install a Git, we can install Git, okay, in your laptop, or what you can do, you can install Git on your instance, a single line. Okay, so if it is a Windows, you want to download from a Git repository and you want to install. If it is a Linux, if it is a single command, sudo apt-get install Git. That's all. You want to create a GitHub repository separately. So this is the repository, github.com. So now we can find we have GitHub, we have GitLab and Bitbucket, that thing that we have talked about. So developers agree that GitLab and GitHub have the best interfaces. Many developers prefer GitHub because it's more popular and they are used to navigation. Our teams using Jira benefit from how seamless integrations with Atlassian ecosystem. So it depends upon your requirement. It depends upon what we are doing. Okay. So it depends upon your client requirement. So each and everything will have its own features. While GitHub comes with lot of features and allows you to create your own workflows, Bitbucket arguably has more flexibility built in. Okay, Bitbucket can also import from Git code plus Git sources. It all depends upon. So now our curriculum focuses on GitHub. If you want, I will let you know at the end GitLab. Yes, this is all about the flow associated with today's agenda. So what is DevOps life cycle and what components there is, what activity in this DevOps. So tomorrow we will start working with the Git, we will install Git and we will working with Git on tomorrow. Okay, yes, clear?
Ram, 15 minutes, 15 seconds, this in between the Jira came in. The Jira, what we perceive is just